What if the solid ground beneath your feet wasn't solid at all? Welcome to Class Bites. Today, we're uncovering the powerful forces of plate tectonics that are constantly reshaping our world. The ground beneath our feet feels solid and dependable, a permanent stage for the drama of life. Yet, this perception of stability is an illusion crafted by the slowness of geologic time. The surface of our world is a dynamic mosaic, a collection of immense, rigid slabs of rock called tectonic plates that are in constant, albeit imperceptible, motion. These plates, bearing both continents and ocean floors, glide over a hotter, more pliable layer of the Earth's interior, driven by the planet's immense internal heat. This perpetual journey, known as plate tectonics, is the master architect of our planet's geography and the engine behind its most formidable natural hazards. It is a theory that reveals how Earth's most dramatic features, towering mountains, explosive volcanoes, and violent earthquakes, are all deeply connected to the slow dance of these colossal plates. The places where these plates meet are called boundaries, and it is here that the planet's creative and destructive forces are most vividly on display. Most of the world's earthquakes and volcanic eruptions occur not at random, but in concentrated zones that trace these very edges. There are three main ways plates interact at these boundaries. They can pull away from each other, crash into one another, or grind sideways past each other. Each type of interaction unleashes a unique set of consequences, powerfully reshaping the world. When plates pull apart, a process known as divergence, magma from the Earth's mantle rises to fill the gap, creating new crust. This process, happening mostly unseen on the ocean floor, forges vast underwater mountain chains called mid-ocean ridges. On land, this same pulling apart can create immense rift valleys, gradually tearing continents asunder. While dramatic, these divergent boundaries are typically associated with smaller earthquakes and less explosive volcanic activity. The most geologically tumultuous regions are where plates collide at what are called convergent boundaries. The outcome of such a collision depends on the type of plates involved. When a dense oceanic plate collides with a lighter continental plate, the oceanic plate is forced to bend and plunge downward into the Earth's interior in a process called subduction. As the plate descends, it heats up, releasing water and melting the surrounding rock to create magma. This molten rock, being less dense than the material around it, rises to the surface and can erupt with tremendous force, building chains of volcanoes along the coast. The Andes Mountains in South America are a spectacular example of this process, a line of volcanic peaks born from a subducting oceanic plate. When two continental plates collide, neither is dense enough to be forced underneath the other. Instead, the immense pressure causes the crust to buckle, fold, and crumple, thrusting rock upwards to form gigantic mountain ranges. The majestic Himalayas, the highest mountains on Earth, were born from such a monumental collision between the Indian and Eurasian plates, a process that continues to push the peaks higher even today. These collision zones are also responsible for some of the most powerful earthquakes, as vast amounts of stress build up in the compressed rock. The third type of boundary is where plates slide horizontally past one another, known as a transform boundary. Here, the plates' rough edges snag and lock against each other, while the rest of the plates continue to move. This causes an incredible amount of stress to accumulate over decades or even centuries. When the friction is finally overcome, the locked sections suddenly snap and release all that stored energy in an instant. This release creates seismic waves that ripple through the Earth's crust, causing the ground to shake in an earthquake. The San Andreas Fault in California is a famous example of a transform boundary, where the Pacific Plate grinds northwestward past the North American Plate, building the stress that fuels the region's frequent earthquakes. Earthquakes are the most direct and sudden manifestation of plate tectonics, but their power can trigger another equally devastating hazard, a tsunami. A tsunami is not a single wave, but a series of enormous waves, most often generated by a sudden movement of the seafloor. The most powerful tsunamis are born at subduction zones, where the collision of plates can cause a massive and abrupt vertical displacement of the ocean floor.
When a locked section of the boundary suddenly ruptures in a powerful underwater earthquake, a vast area of the seabed can be thrust upwards, lifting the entire column of water above it. Gravity pulls this bulge of water back down, creating waves that race outwards in all directions at speeds comparable to a jet airliner. In the deep ocean, these waves may be barely noticeable, but as they enter shallower coastal waters, they slow down and their energy becomes compressed, causing them to grow to terrifying heights before crashing ashore. Through these interconnected processes, the theory of plate tectonics provides a unified explanation for the planet's most dynamic and hazardous events. It tells a story of a world in constant transformation, where the slow, relentless movement of rock slabs can build breathtaking mountain ranges over millions of years and unleash catastrophic destruction in a matter of minutes. The very ground we stand on is a product of this ancient, ongoing cycle of creation and destruction, a testament to the immense power churning deep within the Earth.
Thanks for watching. Please like, subscribe, and comment below with your thoughts or what topic you'd like me to cover next.